2, 1. So quadratic functions, I'm going to talk in a few examples for maximum and minimum. So finding the maximum and minimum from a quadratic function. Now in this particular topic, so when you take a quadratic function, so what you see here on the screen, you basically see kind of two parabolas. One is pointing upwards, the other one is pointing downwards, and you have your quadratic in your standard form. Now, when you're studying these quadratics, so your maximum and minimums, so I'll take the one in blue that you see there on the graph. So here is your minimum, okay, so that you see in there. I'm going to zoom in here. And the ultimate goal will be, okay, so how do I find this minimum? So if I wanted to find out exactly what this is, so how will I do that, right? So this is the minimum, and it will be the value of the y value of the, I guess, the dependent variable. Now here is your maximum on the other parabola right there. And so for that one, so this one, if you take this, all right, so it will be your maximum value. Now, why are they called maximum and minimums? Is because of the fact that if you would take the entire parabola and you plot it out, those are the actual minimum values. So this is the minimum value on the right-hand side. That's what you have in here. And that will be found. Basically, what we're searching for is trying to find the value of the vertex at that particular point. So let's say the vertex was hk, where k is the value of your vertex right there. And then the same thing can happen right here, where it is your maximum right here. And here is the minimum value. So minimum and maximum values. So those are the ones that we're going to be trying to find in some particular way. All right. Now, for quadratics, you can be given the quadratic in many different forms, right? So you may recall, you can have it in standard form, which is like this, which is kind of the worst way to be able to try to find this maximum or minimum. You can be given the quadratic in the vertex format, which would have been, so a, you can transform this by completing the square, and that would have been looking something like that. Or it can be in factored form, where you basically know these values of the zeros of the parabola in some particular way. Those are going to be the three different forms. So let's take a look. I love showing this stuff through examples, so let's look through it in that particular way. So here are three examples. So the first one that we have right here, so this one, is y is equal to 4x squared plus 12. So this is kind of given as a relation, not really as a function. But in this particular format, this is actually in already our favorite form, which is the vertex form. And now, if you've forgotten the vertex form, I will put up a link up above to that, just in case. All right, so you can take a look at that, and then working with completing the square there, it will help you. Now, in general, what we want is we want to be able to find, okay, does this have a maximum and minimum? And for quadratics, it always will have. Now, the point will be, is it a maximum or is it a minimum? And then how to tell that. And if you take this example, so if we break this down, so this is basically in the form that we love to see this, and that is the vertex form, which kind of looks like this, where this is your vertex right here, h and k. Now, why is this in this form? Well, because of the fact that if you write this out, so this is kind of, so if I'm going to expand this, so notice this is what we have, where your a, that's your 4 right there. All right, your vertex right there is basically 0 plus 12. That's what we have happening here. And the a is going to tell us if the parabola is opening up or down, and it's going to tell us, is this going to be a minimum or maximum? So notice within here, so what I have is that this is a 4, and because it's positive, so I know that this parabola is going to be opening up upwards, something like this. Now, if it's like this, that means what I'm dealing with is some kind of a minimum value. Now, where do we find this minimum value? We always find it at the vertex, and we want to know what the y value of that vertex is, or the output. Now, because this is already in the vertex form, we know that this point right here is nicely 0, 12. And our minimum value is going to be 12. So for this example, so for our first example, we have found our minimum value, and that minimum value is basically 12. Now, does it have a maximum value? Well, because there's no restrictions on this particular parabola, then the parabola look and opens upwards, and it goes on forever. So the bigger the x that you have, both in the positive and negative directions, okay, so if you have a bigger and bigger and bigger and bigger x, the result is going to just give you a bigger and bigger result. So there is no maximum here because it goes on to infinity, okay, because this parabola just keeps opening up, okay, and goes on forever in that way. Now let's take a look at the second example. So in this one, what we have is we do have, so it looks like a function, and unfortunately it is not in one of the easier formats that we can actually tell what the maximum and minimums are. So this is in its factored form. So what I have is I have a -3, so that's one factor. I have x plus 2, which is another factor. And I have a 3x minus 1, which is another factor. Now, I am able to tell quite a bit from this piece of information. These two factors, so not necessarily the -3, but this and this, okay, these do tell me what the zeros of this function are. And so my parabola, so from here, what I have is, so here x plus 2, so this particular 0 is going to be x is equal to -2. And then for the second one, which is this one right there, so here, my 0 right there is going to be, so if I solve for x here, I'm going to find that x is basically 1/3. So what that tells me is that if I would plot this out, so if I have this in this format, it tells me that my parabola is going to be going through, so -2 and then 1/3. Now, which way does it open? So I can actually tell and see what that is. Now I have to be a little careful, okay, within my factors. So I do have, now I can expand this out. So let me expand it. And it's going to give me, so -3. Okay, so I'm just expanding that whole thing out. We do it in fast forward fashion. So it's going to give me 3x squared there we have it. That is the expanded form. So I just had it from the factored form and then I just expanded it out. So here is my standard form right in here. And we know that in here, so this is -9. So what that tells me, so that -9 is basically my A. So that will tell me if this parabola is pointing up or down. So it will be pointing downwards. So I know that somehow this thing is going to look something like that. Now, I don't really know what that vertex is yet. And again, I might be off, okay, as I'm plotting this. But I do know that it is down. And if it is down, so that means this is going to be my maximum value. So I will have a maximum value for my output. Now, the question is, what is it? Now, how do you find it if it's in standard form, right? Well, the value that you can find is, you can, of course, plot it and find it. So you can use something like decimals, that's one. You can put it into the vertex form by completing the square. So that's another way. And then, of course, another way of doing that is, you may recall, you can find the line of symmetry. Now, because we already have it in factored form, so we kind of know that our line of symmetry that we are dealing with in this particular example is going to be running, okay, so somewhere along in here. and it's going to be halfway between these two particular points. So I don't really have to complete the square here. I can kind of cheat, okay, because I know that the middle point, okay, so between those, so if I take -2 and then I'll add this, so that's going to give me the value, right? So if those are the two values added together. Now, so this is -6/3 plus 1/3, which is 5/3. And if I divide this by 2, that's going to give me the middle ground, which is going to be basically 5/6. So somewhere within here, okay, so what I have, and this is going to be, let me just make sure, so this is negative. So it's -5/6. So this is the value of your x at -5/6. That is where the line of symmetry goes through. And we know that this is going to be the vertex form. So now, if I want to find out what this maximum value is, and since I know, and let me put an extra page in here, just to add it. So since I know, okay, so within here, so I have -9x² minus 15x plus 6. That is my function, which is h of x. I'm going to substitute this -5/6, so I don't have to complete the square in any way. And let me substitute that in. All right, so there you have it. Okay, so it would be about 12.25. That would have been our maximum value. So if it is in factored form, that's something that we can do. We can just use the line of symmetry and then find the maximum value. And here it is for us. The next example, and that I have for you, so within here, this is completely in standard form. So unfortunately, so copy. This isn't in factored form in any way. It is not in vertex form. So how do I find out the maximum or the minimum of this quadratic? Well, what I will do is, first off, okay, so I take a look at this, and this will tell me if I'm going to be dealing with a maximum or a minimum. So this one is going to be opening up. And if it's opening up, what I'm dealing with is a minimum. So I know that that's what I will have. Now, sure, I can find the line of symmetry again, like I did in the previous example. But to show you, I guess, on the different method, I'll change this back into and complete the square. All right? And so here, in terms of completing the square, okay, so I will use these first two terms to complete the square, and I will take out the 2 first, because I want to get rid of that. All right, so this is what I'll have. The -3, so this is going to be towards the end there. And now, to complete the square, we take our value for 3, we divide it by 2, and then we square it. And then we have to subtract. So we add and subtract, so that's the completing the square. This will give me 2. And now from the completion of the square, so that's from right here. So this is a perfect square. And what we have is x, so it's positive, and then 3/2 squared. Now this term right here, so that's minus. Let's not forget the 2, which will multiply that. So 3/2 squared, and then minus the 3 there at the end. And finally, so super close. And so from right here, so this is going to be 2. This is 9/4 minus 3. And from these two right there, so what I have, this 2 goes into the 4. There you have it. And that's going to give me -9/2. The 3, that's the same thing as 6/2. And that's going to be minus 15/2. All right. So in full, my quadratic after completing the square is this. And you will notice that now, so again, so 2, so it is a minimum, and my minimum is going to be, there's nothing to graph, we don't have to graph it, it's going to be the negative 15 over 2. So that's going to be the full value. Now, let us actually graph the original and just see how you can use that. So, you know, I'm going to take out decimals right here. And let's plug it back in here. Okay, so what do we have? So here's my original. So this was 2x, so within here, so 2x squared plus 6x minus 3. All right, so let's see here. Well, we don't need it to be that big. Within here. All right, so we definitely do have a minimum, and notice that's where it is. So negative 7.5, which is the negative 15 over 2 that you see there on the left-hand side. All right, so that would have been our parabola. So that's how you can find these maximum and minimums. Now, just to complete this and to show you, so here's an actual word problem where this kind of maximum and minimum comes into play. So for instance, what if you had a cost of making a product and it was modeled by a quadratic equation? So here's our quadratic equation that we're dealing with. It is being restricted within here. And notice this x, it represents the number of strands used in stitching a product. So we can't really have negative values, and it says, I guess the maximum is 100 strands that we can use. And the question is, how many strands are needed in order to optimize the costs for this product? If you're going to be optimizing costs for yourself, you definitely want to try to minimize them in some particular way. So you don't want to be overpaying for these. And let's take a look and see, you know, what value for x we could find that will optimize or minimize this particular cost. Now, I can see that this quadratic is in standard form. Now, it has very big coefficients here, especially the b and c, but this is a positive 10. Now, just from that, I know that it will be minimum because my quadratic is going to be opening up upwards like this. So that's the first thing. Now, how do I find this minimum, which is going to be right here? So I need the value of y. I can again, so I can graph this. So that's one way of doing it. Number two is I can find the line of symmetry if I wanted to, if it's possible, all right, in some way. Or I can just complete the square. Okay, so either of those methods will work. So first I'll complete the square. I'll do it in fast forward fashion so that you can see it. And then I'm going to graph it for you. All right, so let's do that. Let's complete the square first. All right, so that's the completion of the square. So now that we have this, we basically can take out our vertex. So it's going to be 50 and 35. So notice this is our minimum cost, which is actually not bad at all. All right, so that's our minimum cost. Now, within here it says how many strands are needed in order to optimize the costs. Well, if this is the minimum cost, then what do we need? How many strands? Well, it's going to be 50 strands. And that would have been your answer within here. Now, notice it is the x value because they're asking for the strands. But if you were trying to optimize the cost, it's actually at 35. That would have been the minimum cost possible. Now, what if we graphed this? You know, would we see something similar? So if I take this, so let's go back in here. There you have it, all right? So it's graphed right there for you. And indeed, it looks like it's at the value of x that we actually minimize the cost. All right, so that's what you would have. So hopefully this now gives you some idea on how to minimize and maximize, how to find those on your quadratics. Thanks for watching. We'll see you in a future video. Okay, cheers everybody. Bye.